Hello students, welcome back to Standard 10 Mathematics 1 digital class. Today we are going to start with the new chapter Arithmetic Progression. Sequence. A set of numbers where the numbers are arranged in a definite order is called a sequence. Example 1, 4, 9, 16, 25, 36, etc. Here 16 is equal to 4 square. It is at 4th position. Similarly, 25 is equal to 5 square is at the 5th position. In this set of numbers, place of each number is determined. Another example, set of natural numbers. Natural numbers means 1, 2, 3, 4, etc. So that is written in an order. In this order, we can tell the position of any number. For example, 3. 3 is at 3rd position. So, this set of numbers are written or arranged in a definite order. Therefore, it is called a sequence. Terms in a sequence. In a sequence, ordered terms are represented as T1, T2, T3, etc. Tn, etc. So in general, sequence is written as set Tn. If the sequence is infinite, for every positive integer n, there is a term Tn. Now let us do an activity. Some sequences are given below. Show the positions of the terms by T1, T2, T3, etc. First sequence is 9, 15, 21, 27. Here what is the first term? First term of the sequence is 9. So we write T1 is equal to 9. Second term is 15. So we write T2 is equal to 15, T3 is equal to 21 and so on. Second example 7, 7, 7, 7, etc. All the terms are equal. So here T1 is equal to 7 and what is T2? 7 only. T3 is also equal to 7. The next sequence is minus 2, minus 6, minus 10, minus 14, etc. Here T1 is equal to minus 2, that is the first term. Second term T2 is equal to minus 6 and third term minus 10. Let us find the relation in these sequences. Let us understand the thought behind it. So here some sequences are given. So we have to study the relation in these sequences. First is 1, 4, 7, 10. So what will be the next term? So the similarity is that next term is obtained by adding a particular number to the previous number. So here first term is 1, second term is 4. So 4 is obtained by adding 3 to the first term. 7 is obtained by adding 3 to the term 4 and so on. So here the term will be 13 and the next is adding by 3, we will get 16. Next one, next sequence 6, 12, 18, 24, etc. So The similarity is that next term is obtained by adding a particular number to the previous number. So here each term is obtained by adding 6 to the previous term. 6 plus 6, 12, 12 plus 6, 18, plus 6, 24, plus 6 will give you 30, plus 6, 36. Next sequence is 3, 3, 3, etc. So each term is obtaining by adding 0 to the previous term, because here all the terms of the sequence are equal. So here 0 will come, here 3, 3, 0. But if you check the fourth sequence, 4, 16, 64, etc. In this sequence, the next term is obtained by multiplying the previous term by a particular number. That is 4 into 4, 16. 16 into 4, we will get the next term 64. 64 into 4, here we will get the number and so on. That means each term is obtained by multiplying the previous term by a particular number. Then next sequence, you can study the next sequence. Each term is obtained by adding minus 0.5 to the previous term. Here sequence is 1 cube, 2 cube, 3 cube, etc. Here 1 cube is 1, 2 cube is 8, then 27, etc. So here we cannot find out a particular relation. Here we can say the examples 1, 2, 3 and 5. Next term is in each of these sequences, the next term is obtained by adding a particular number to the previous number. So each of these sequences is called an arithmetic progression. So here which are the arithmetic progressions given? 1, example 1, 2, 3 and 5. Now what about example 4? Sequence 4 is not an arithmetic progression. Why? Because in this sequence, the next term is obtained by multiplying the previous term by a particular number. That is, multiplying the previous term. This type of sequences is called a geometric progression. Here in 10th standard, we are not going to study geometric progression. We study only arithmetic progression. Sequence 6 is neither arithmetic progression nor geometric progression. So next, let us do another activity. In the given sequences, observe how the next term is obtained. Here the sequence is 100, 7, 40, 10, etc. First term is 100, second term is 70. So 70 is obtained by adding a particular number in the previous term, that is 100. That means which number we have to add? Minus 30. 100 plus minus 30 is 70. 70 plus minus 30 is 40. 40 plus minus 30 is 10. 10 plus minus 30 is minus 20. Minus 20 plus minus 30 is minus 50. So, the difference between two consecutive terms is constant. If we take the difference between any two consecutive terms, that is 170. What is the difference? Minus 30. 70 and 40. Difference is minus 30. 40 and 10. Difference is minus 30 and so on. That means in the sequence, every term is obtained by adding a particular number in the previous term. Therefore, the difference between two consecutive terms is constant. So, You can study the other examples also. The first example, the difference is negative, that is minus 30. And the second example, it is 3, which is a positive number. And the third sequence, it is 0. Now, if the difference between two consecutive terms is constant, then it is called the common difference and is generally denoted by letter D. So, this difference between two consecutive terms, it is defined as the common difference and it is denoted by the letter D. Now, we can define an arithmetic progression. In the given sequence, if the difference between two consecutive terms, that is Tn plus 1 minus Tn, is constant, then the sequence is called arithmetic progression, which is denoted as AP. In this sequence, Tn plus 1 minus Tn is equal to D is the common difference. So, common difference means the difference between two consecutive terms. In an AP, if first term is denoted by A and common difference is D, then T1 means A, that is the first term itself. T2 is equal to A plus D, that is the second term is obtained by adding first term by a number which is called the common difference. T3 is, that is T2 is equal to A plus D. T3 is equal to second term plus common difference. What is the second term here? A plus D. So, A plus D is equal to A plus 2D. Therefore, we can write an AP, arithmetic progression, having first term as A and common difference D is A plus D, A plus 2D, A plus 3D, etc. Now let us discuss an example of AP. Arifa saved ₹100 every month. In 1 year, the total amount saved after every month is as given below. That is, each month she is saving ₹100. So, first month saving is 100. Second month 100 plus 100, that is 200. Third month 200 plus 300, which is 300, and so on. So the numbers showing the total saving after every month are in AP, that is 100, 200, 300, 400, etc. forms an AP. Let us do one question. Check whether the given sequence is an AP or not. If it is an AP, find next two terms. The given sequence is 5, 12, 19, 26, etc. So here one sequence is given. We have to check whether the given sequence is an AP or not. If it is an AP, we have to find the next two terms. So here what is the first term? First term T1 is equal to 5. Second term T2 is equal to 12. T3 is equal to 19. Now we have to find the difference between two consecutive terms. That is T2 minus T1. 12 minus 5 is 7. 19 minus 12 is 7. Similarly, 26 minus 19 is also equal to 7. So here first term is 5 and the common difference, which is constant, is 7. So the given sequence is an AP. Next two terms in this AP are, how we will find out the next terms? A plus D. First term is 5 only. Second term is A plus D. That is 5 plus or T1 plus D. 5 plus 7. is 12. Third term is 19 and fourth term is 26. We have to find out the next two terms. 26 plus 7. Why we are adding 7 here? Because the common difference is 7. We get each term by adding common difference to the previous term. So 26 plus 7 is equal to 33 and the next term will be 33 plus 7 is equal to 40. So the next two terms in given AP are 33 and 40. So here first term is 5. We write T1 is equal to 5. Second term T2 is equal to 12. Third term T3 is equal to 19. First we will find out the difference between the two consecutive terms, that is T2 minus T1, that is 12 minus 5 is equal to 7. Next is T3 minus T2, that is the third term minus second term. 19 minus 12 is equal to 7. So first term is 5. Common difference D. It is a constant, that is we are getting the same number 7 only. So D is equal to 7. That means this sequence is an AP. So how will you find out the next two terms? Next two terms. Here fourth term is 26 by adding 7 to this, that is 26 plus 7 is equal to 33 and next term is 33 plus 7 is equal to 40. So next two terms in given AP are 33 and 40. Next question. The first term A and common difference D are given. Find first four terms of AP. Here what is given? A is equal to 200 and D is equal to 7. A means what? It is the first term. T1 is equal to 100 and D is equal to 7. How we will get T2? T2 is equal to T1 plus D. That is 200 plus 7. Solution. Given A is equal to 200 and D is equal to 7. Then we can write first term T1 is equal to 200. Then T2. Second term is obtained by adding the common difference 7 to the first term 200. That is T1 plus D, which is equal to 200 plus 7, 207. T3. T3 can be obtained by adding D to the second term. Second term plus common difference. T2 plus D. T2 is what? 207 and common difference is 7. So 207 plus 7, which is equal to 214. T4 is equal to, T4 is obtained by adding common difference D to the third term, that is T3. So T4 is equal to T3 plus D is equal to 214 plus 7 is equal to 221. So the AP is 200, first term is 200 T1, then 207, 214, 221, etc.